Hi there everyone, and welcome back to the channel Machining with Joe, a channel where I share with you guys my journey as a beginner machinist. So we've got a lot to get through today, so we're going to have to make this really speedy, show you what I've done already, and we'll go through what's needed. So this week I've already fitted the Y-axes on the milling machine, so the milling machine now is all set up and working, which is really good. So in a minute I'm just going to show you how I've set the Y-axes up, all the brackets and fixings I've had to do to get that to work. And after I've gone through all that with you, we've got a few things that I want to get done today. I need to machine a stop so when I wind my table forwards it doesn't collide with the end of the scale. So that's a really important little mod I need to get done, just because unfortunately how I've had to lay this out, I've lost about 10 mils worth of travel on the table, and as a result of that, when you're winding the table towards you, if you wind it too far it's going to break the glass scale. So that is something I really need to get done today. And after I've done all that, basically what I want to do, now just 2 seconds, you're all probably familiar with these 1, 2, 3 blocks. I imagine anyone at home that's a machinist has got a set of these, and what you know about these is they're super hard and also super accurate. They've been ground to, I think these ones are 0.05 mil or 0.005 mil. Either way it's really accurate. And basically what I want to do, I want to block these up in the vise, and with an edge finder I want to edge find on one side, then I want to go to the other side, edge find on that, and I want to see what measurement my DRO gives. And by measuring these with a set of verniers, I want to see if the verniers match what the DRO reads. I'm going to do that on both scales. I'm going to do that on the X and on the Y, and we'll see how accurate this DRO is. Because when you buy these import DROs, a lot of them will give like a tolerance, and the tolerance on this was 0.05 millimeters. So in theory that should be 0.05 millimeters within spec of this 1, 2, 3 block. So the reason I didn't film any of this modification this week is, to be honest, I didn't really know how I was going to do it. So it was just a sort of like make it up as I go along, and I personally think it's turned out really well. So as you can see down here, I've got my scale running along the back of the base of the mill, and down here we've got the encoder. But the encoder needed a way of fixing to the saddle as such to make it that when you wind it backwards and forwards it actually moves. So to do so I used these set of brackets that came with the milling machine kit, and by machining a small square block down I managed to attach the bracket onto the saddle using this set of weird angles going on here. That means when the saddle moves, the encoder also moves backwards and forwards along the scale, which is going to give our DRO the reading it needs. But the problem we've got here, or the problem I've got should I say, is it's fine when it moves away from us, but when it moves towards us, because of the way I've mounted this to the base, I couldn't mount this any further towards me. So as a result of that, this orange bit down here, I don't know if you can see that on the camera, yeah, you should be able to. This orange bit will actually hit the end of the glass scale, which is really bad because if I then carry on winding it's going to cause some serious damage in there. So realistically, for using the mill, I've only really lost about 10 mil of travel. I don't think it's going to be the end of the world. If I really need that 10 mil worth of travel, I can always just take these 2 bolts here out. But what it does mean on day-to-day usage, if I forget about this and carry on winding, this is going to be broke, and the on and off work I've done over the last couple of weeks is going to be absolutely pointless. So what I need to do is I need to make a stop on the front of this machine. So how I'm thinking this stop's going to work is the front of our saddle here overhangs the base by approximately 12 mil. So if we can mount something to the base with a 12 mil recess in it, in theory, once this comes over 12mm, it will hit our stop and stop moving, or at least make it feel like it's really hard to move, and that should give me the incentive to stop. So what I'm thinking is using some of this 25mm bright mild steel. I'm going to mill out a 12mm recess in here, drill a couple of holes in the bottom, and then mount that down here. So once I've wound out too far, it's going to hit the stop and put a stop to me moving any further. So that's the plan, because I really don't want to break this glass scale by forgetting I've got that little bit less travel. So this is a really important little upgrade I need to do after fitting the DRO. So I've got my part chucked up in the lathe now, and I'm just going to face off the ends before mounting it in the centre of the vise to do the majority of our milling. So this is the first time I've used my DRO for a little project, so this should be pretty good. So I'm going to zero that there. So literally just trying to clean up the ends of these, nothing too crazy. In total I've taken off 0.2mm on these. So let's see what the finish is like on that. So that's just a 14mm carbide roughing end mill I've got, and that's given a nice finish on there. Where's my vice handle? Always losing this vice handle. Just a quick idea for a future video. I'm always losing this vice handle. Maybe I need a way of mounting it somewhere, or maybe I'm going to make a bigger vice handle so I don't lose it, because this thing is always going missing. Where has it gone? Ah! Vice handle, got it. Got it. Right, let's flip this part and go again. Right. That is the ends done now. This is no way to scale, but just an idea of what I want to do is this red bit of pen here. Let's take it back here. So I've got some red pen here, say for example. I want to take out like a 12mm section all the way along there. So bang, I can step that and put it against my saddle. So that's the little project I need to get on with now. Shouldn't take too long. I'm just going to quickly deburr these edges. Not that there's much of a burr there. And then we'll start machining this little bit out. So to start with, to mill this out, I need to set my depth. So what I'm going to do, I'm going to place a little bit of paper under there and come down to it touches. Once it touches, I'm going to zero my DRO there, and with that zeroed I can move this way, move my workpiece away, and I'm going to come down according to the DRO 12mm. Get it to it's nearly there. 11.93. Just lock this off now and use my fine adjust on that. 12mm there. That's good. So I've got the depth set, and now all let's to do is mill some of this out. So let's give it a go. Touch off on my work. It's on the Y position now. Zero that there. Start with 0.5mm passes and we'll see how that goes. So half a millimetre seemed quite easy. Let's mill out a whole mil. So 1 millimetre, and we'll see how that goes. So on the conventional milling passes, I think I'm going to stick to 1 millimetre, and on the climb milling I think I'm going to stick to 1/2 mil. That seems like quite a good depth at the minute. So we're coming up to our finished pass now, and this will actually transition onto what we want to do next actually, because although this isn't an accurate bit of machined block, I have, according to the DRO, taken off of 12 mil. And let's just stop that there. According to the DRO, I've taken off 12 millimetres on this bit of stock, and as we've got the original bit of stock at the bottom, I could actually clean this up and measure this now. So I think that's what I'm going to do. I'm going to measure this and see exactly how accurate this DRO has come out at. Obviously this isn't going to be as an accurate test as later on when I do it on the 321 block, but it's going to give us a good idea on how accurate these import DROs are. So let me clean this up, deburr this, and I'll come back over on the bench where we can measure it and check exactly how accurate this DRO is. Right then, time to find out how accurate our DRO is. But to start off with, can I just say, look at the finish on that. That right there is the reason I absolutely love machining. You can turn a random bit of metal into, I'm going to call that a piece of artwork. The finish is outstanding, and it just looks cool. Like, you've turned, like I just said, a bit of metal into something that's going to serve a purpose. So I'm so happy I got the mill, and really happy that the DRO seems to be working okay. But it's time to find out if it's working okay in the real world. Does what it's showing on the screen actually relate to what it's actually doing? So to start off with, I'm going to measure the original overall diameter of this part. I'm not using a ruler this time, I'm going to use my calipers, because to do this I want to get a fairly accurate measurement. Right, they're on 0. And what bit do we machine off? Right, we use the DRO on that bit. So the original overall diameter, let me just write this down, was 24.96 millimeters. And the bit that we machined, make sure these are on 0 again, we were left with a measurement of 13 millimeters. So if my maths is correct on that, we've taken off 11.96 millimeters, and our DRO showed that as 12. So we've got a discrepancy of only 0.04 millimeters. So that is well within spec, given that this import DRO said it can measure as close to 0.05 millimeters. So I would say that is a complete success. We've got a DRO that can now accurately measure our stock, and because of that I don't have to rely on the imperial hand wheels anymore. I can just use my metric DRO and get some super accurate cuts. All that's left to do now really then is to drill a couple of holes in this stop, get it mounted to our base, and just test its function and make sure it's going to work. So I'm going to do that. I'm going to come back when we've got all that mounted, and then after that I just want to do a few more measurement tests. Like I said, I want to put some 321 blocks in my vise using an edge finder, edge find on one side, edge find on the other, see what the difference is, and then measure the 321 block with a set of verniers again and compare that to the readout that my DRO's given. My carriage will not move anymore. Oh God. take this handle off and let's show you what's going on. So down here I've got the stop all mounted. So off camera I've just drilled two 6mm holes, drilled a 5mm hole into the base and tapped that out to an M6, and I've just got two M6 bolts down here. So I tell you what, it works brilliantly. Let's just try it again. So you wind it down, gets to that stop, and that's it. Can't move any further, and it's got enough room on the DRO that nothing's going to get damaged. Jesus, these handles are so dodgy. I might have to put a stop onto these. So the stop's all done. We've sort of tested how accurate this is to measure, and the next thing I want to get done is block some 1, 2, 3 blocks up in the vise, edge find on each side, zero it as I go, and using the DRO measure these and see how accurate the DRO gets these compared to my vernier calipers. Right, moment of truth then. I've got my 3, 2, 1 block up here in the vise, and I've got my edge finder mounted here. So the way this is going to work, I'm going to edge find on this side, zero my DRO, I'm then going to edge find on this side, and I've then got a minus 6mm for the nose of the tip, and after I've minus the 6mm, the reading that we then get should be how wide this block is. So I'm going to do this on the x-axis, and then I'm going to flip the part and do this on the y-axis and see what two findings we get, and after that I'll measure this with my vernier calipers and see how accurate it is. So let's do this. Right, so I'm just going to wind this in till the nib centralises, and then we know we're on centre. Right, I've gone a little bit over there and it's kicked over now, so I'm just going to back it off so it centralises again. Alright, we're central there. So I'm going to zero my DRO. And wind it along, winding, winding, winding. Right, we're going to wind that in until that centralises. And it's kicked over there, so we'll just back that off. There we go. So on the x-axis we've got a reading of 82.260. Let's make a note of that. So we've still got a minus 6mm from this, but for now I'm just going to flip the part and do the test again and see what reading we get. So we're just coming back. I've already used the edge finder and zeroed my DRO on this back piece. I'm now just going to do the final bits and see what we're left with. Perfect, bang on. And our Y reading is now, so we've got 82.320. So before on the x-axis we had 82.260. So at the minute the x and y axes are basically reading exactly the same. So with our 6 minused off there, we've got 76.320. It's the moment of truth now. Let's see how wide this actually is. So this block is measuring in at 76.26mm. So that means we've got a difference of 0.06mm, which is just a little bit out of specification of what the DRO manufacturer says. But when you take into account the edge finder has a tolerance, and obviously the actual measuring implements I'm using have a slight tolerance, I'm going to say that's within spec for what I do in this workshop. So I'm really happy about that. Right then, that about sums up this video, guys. For those of you who are still watching, I hope you found this video useful and entertaining. If you are still watching and you haven't yet subscribed, then please hit that subscribe button. It really helps the channel out. But for now, go back and watch any of my previous videos that you may be interested in, and I'll see you next week back in the workshop. Have a good one, guys.